Hello, we're going to be doing Math 114, 3.6, and continue with linear inequalities in two variables. Okay? So, our first objective is to determine whether an ordered pair is a solution of an inequality. But before we have to do that, we have to understand what that inequality means. So let's consider what the graph of a linear inequality in two variables look like. A line divides the plane into three parts. The points on the line, the points below the line, and the points above the line. Well, what this is trying to tell you here is that if we have a line that goes like this, I don't care how the line looks. It can look like that or something like that. This is divided into three parts. It has the point, any point that is within the line itself. That's the first part, which is talking about points on the line right there. Then points below the line. That could be points here. Again, I don't really care where. Okay? And which is the points up below the line, and the points above the line, which could be represented by something like this. Again, I don't care how the line looks like, it's still the same. Okay? So the graph of a linear inequality that involves either greater than or less than is half a plane. The graph of an inequality that involves either greater than or equal to, or greater than and equal to, or less than and equal to, is a half plane and a line. So this separates things. That means on this one that if I have a line that it's only above the line, it's going to count something like this. And since this does not include the line, we shall use dotted lines. However, this one, we do have a solid line because it is part of my answer and it includes wherever that statement is true. We'll get to that part a little bit later. So let's continue. So here it says, does the ordered pair 2, 4 satisfy 3x minus y equal less than 5? That is really simple to determine. We're just trying to see if this statement is true. So how can we do this? Well, we know that the 2 represents the x and the 4 represents the y. Therefore, I have 3 times 2 minus 4 is less than 5. Let's evaluate this. This will become 6 minus 4 is less than 5. And now we have 2 is less than 5. Is this statement true? Yes, it is true. Therefore, the ordered pair is a solution. Okay? Objective 2, graph a linear inequality in two variables. Now this involves several steps. Yes, I do. So let's first have to do our little graph. And this is in the format of negative y. X minus y is less than 6, which is this is standard form. Again, you can use y equals mx plus b, which is slope intercept. I don't really mind how you do it as long as you do it right. Since this isn't already in this format, let's use our little table to use the standard form. Take advantage of it. So if I allow y equals 0, then I have x minus 0 is less than 6. So I have that x. So that's what we have. Now let's allow x equals 0. So x minus 6. Okay, so I have this. Then I'm going to go this way. So I have that. Okay, so I have this. Do you notice something changed? I hope you did, because we started 0 minus y is less than 6. Then we know that 0 doesn't affect it in any way. So we have negative y is less than 6. Then it all went from this to y is greater than negative 6. So this is a hint or note. When you divide / multiply across an inequality by a negative number, the inequality flips. Like here. It's flipping, okay? So now that we have that, that means that we have 6, 0 as my first point, and I have 0, negative 6 as my second point. Now we can start graphing, okay? So to start graphing, let's make a graph. And I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? So our first point, I'm going to be red. So that's going to be 6, 0. 1, 2, 3, 4, 5, 6, 0. And there we go. And that green's kind of ugly. Let's do a little purple so it looks a little bit more better. So I have 0, negative 6. Now we have to determine if this has a solid or dotted line. Well, we remember that when we have this, then we use a dotted line. When we have this, then we have a solid line. Since we have only less than right there, then we will have a dotted line. So our dotted line will look something like this. Okay? So we're halfway through with this problem. Now we need to determine what half of the plane makes the statement true. So let's select this so I can go to another page with a little bit more space. So select, copy, and paste. There we go. Let's make this a little bit bigger. And let's remember that we had our points were 0, 6 and negative 6, 0 were our points. And my equation was x minus y is less than 6. Okay? So, hint again. Hint. When your graph does not go through origin, which origin is 0, 0, which would be right there, then you can use origin, which is 0, 0, as a testing point, period. So is our line going through origin? No, it's not. So we're going to use it to test. So we have, remember that this is 0, 0. So we have 0 minus 0 is less than 6. 0 minus 0, 0. Is this true? Yes. Since it's true, that makes that I need to shade. And I'll explain why the shading in a minute. So let's see where to shade. Does this make true? Yes, that means I'm going to shade where that location of that point is, which is the upper part of the plane. This means that all of these points, I don't care which one you choose, will make this true. So let's say we use negative 6, 6, that point right there. That's going to make this true. If I use 0, 0 as we saw, it's going to make it true. If I use 6, 6. It's also going to be true. That means that all those solutions are true, making this our final answer. So this is our graph, and I'm done with this problem for now. Okay? And remember, any point that is within that shaded area that you use will make this statement true. So, following the same deal, but now we have something weird. We have this. Do we have an X? No, we don't. Since we do not have an X, that means that our line is a horizontal line. My question for this is it going to be a solid line or a dotted line? It's going to be a solid line because we have an equal down there. So let's start. That's our graph. This is X and this is Y. Like that. So my line will be this, like this, because it's 0, 0, and it's a horizontal line. Now we need to determine where to point. This is saying, let's translate into words what this thing is saying to us. So all of this says, y is less than or equal to 0. Okay? For to make that true, that means that all numbers must be positive. So therefore, our answer is the top part. Okay? So we're done with that. That was fast. So now we're going to be doing 2x minus 4y is less than 8. Sorry. So again, let's change this. Let's do now, the other previous one we used standard form. Let's now use slope-intercept to solve this problem. Whoops. So let's use slope intercept. So we must look something like so. Okay. So we have 2x minus 4y less than 8. So minus 2x minus 2x. This cancels that. So now I have negative 4y is negative 2x plus 8 divided by negative 4 everything. Remember, divided by negative 4, so that means this is going to flip. So I have y is greater than 1/2 x plus 2. And that's our standard form equation. So now I'm going to do 1, 2, and that's going to be my first point. Then it's the slope is telling me to go up 1 and 2 to the side. So that's my second point. This is does not contain equal anywhere, so our dot, we're going to have a dotted line. Now we need to choose we need to choose a point to test. Again, we're not using origin, so I'm going to use 0, 0 as a testing point. Let me just select this and move it a little bit to the side so we have enough space. So I'm going to test with 0, 0. So I have 2, 0 minus 4, 0 like this. This is going to be 0. Is this true? 0 less than 8? Yes, this is true. So again, 0, 0 is right there, right? And 0, 0 is in the bottom part of the line. So we're going to shade the bottom part of the line. And whoa. Like so. And we're done with that problem. That's all I wanted to do. Again, this is already in y equals mx plus b form. So this is even easier to graph. This is y, 1/2 x, plus 0. So it's already how we want it. So let's start. 1, 2, 3, 4, 5, 6, just in case. So it's 0, 0 for my y-intercept because of that guy right there. Slope, it's telling me to go 1 up and 2 to the side. Now, this one, we do contain an equal sign, so this is going to be a solid line. Now, we have a problem with this. We are using 0, 0. We are using origin. So, we cannot use origin to test. Since we cannot use origin to test, we're going to use the second easiest number. We will use 1, 1 to test in this problem. Okay, so I have 1, 1/2 times 1. 1, 1/2. So is this true? Is 1 greater than or equal to half? Yes, this is true. Our point was there. You can barely notice it, but let's make it a little bit bigger so we can see it. So it's the upper part or the upper half of the plane. Therefore, we're going to shade that. Okay? And this concludes